As part of exercise number 3, we had two exercises. We had exercise 3A. We talked about that in detail in class, where we were looking at creating some scatter plots, creating some brand new columns from which we can extract or permanently extract rates, because we can normalize in our symbology editors, but those are typically going to create per capita. And we talked about some of the issues in working with per person or per capita as opposed to looking at rates like deaths in per thousand or per 10,000. So we looked at these here for exercise number 3A. We're looking at the number of cancer deaths, or that join count that we've extracted from exercise 1 and kind of led into exercise 2 when we did descriptive statistics. Now the other thing that we're looking at here as well is exercise 3B, where we're going through and mapping change. And we're going to look at an exercise right here. So this is exercise 3B, where we have all cancer deaths for 2015, cancer deaths for 2016, cancer deaths for 2017. So we're going to do some simple change detection analysis to calculate the change between these using some of the techniques that we've already talked about already. And just a quick review here for exercise number 3, we're just going to map between two different years, percent change. And so new minus old divided by old. So we need to run these summarizes. We need to run maybe some spatial joins. We also need to add some new columns right here. And so when we look at our zip codes in our particular study area, so what we're looking at here is our zip codes in our study area. We can see the zip codes here. We can see I had some sort of random thing here. I don't know what that means. But what we're going to do really quickly is we're going to look at the cancer deaths between 2016 to 2017. And so we're going to need to create three new columns right here. So we're going to go to our fields view right here. And so we're going to create a column here called Deaths 2016. And we're just going to make this a long integer because obviously this is going to be an integer number like 1, 2, 3, 4, 5. Next, we're going to create one called Deaths 2017. And I would encourage people to look at different years, maybe with the coronary heart disease or something else. So, and then the last thing I'm going to look at percent, and let's go official with the name here that I had. So percent death change. So we're going to click on percent death change. Okay, and this time we are going to make it not a blob. We're going to make it a double precision. So that means that we can store the numbers as well, store the decimal points as well. And up here, I'm going to click Save. So now I have some brand new columns. Brand new columns with the deaths in 2016, deaths in 2017, percent death change. And then over here on the left, I have my zip codes. These zip codes are stored as these zip codes are going to be stored as text because you notice that they're left justified right here. And so what am I looking for here? I'm looking for 2016, 2017. If I right mouse click and open my attribute table, you can see all of the cancer deaths that I have here. Just a couple of things that you can notice right here. If we look at the ACME code or the code 1 right here, these are all of the codes that end with begin with a C. I don't care what type of cancers or anything like that. You can see, tobacco, zip codes, all these other things right here. Okay, so what we're going to do here is, let's go over here. We've got a zip code right here. Now, we do notice a couple of problems right here, and we'll deal with these here in a little bit. Couple of problems here, but we'll deal with these in a little bit. So I've got a zip code here, and I brought this in from a CSV. So first thing we'll do is we'll right mouse click, and we're going to run a summarize. And all this summarize does is count the number of times each zip code appears. If I really wanted to, I could look at something like age in years and calculate the mean of those, as well as other summary statistics as well. Now I'm going to run this, and so I have my cancer death statistics. If I right mouse click and I click on open, you can see my 1252 zip codes right here. If I sort these, you can see the zip codes. I've got frequencies. If I sort these frequencies, you can see 28655 has 127 during this particular time period, all the way down. Now, the problem that we run into here, and I'm not sure if anyone noticed this, if I do a sort ascending or something, you notice that I've got some numbers right here. Ooh, this isn't good. Okay. And you notice these are left justified because when I brought this into my GIS, I probably brought it from a CSV file and it had some of these leading zeros kind of get rid of itself. Why? Because it's treating it as a number here. Now, do we really care about zip codes like 00736? No, because I know in North Carolina, all of them are going to start with a 2. But when I go to run my join here, and I'm just going to show you this because the big problems, and I know Chima talks about this a lot, is the big problems when I go to run my joins here from this summary. All right, I'm going to join my zip to my statistics right here, and you notice there's nothing here that lets me do it. I can kind of validate it right here, but it says it has no matches. Okay, why? Because we're working with numbers right here. This is zip. I'll get rid of this. This is zip. But you notice this is left justified, this is right justified. So one's treated as a number, one is treated as a text. I can simply remedy that. So when I go to my fields view, because a lot of times you're going to run this in the real world. And what I call this is typecasting. Meaning I'm going to call it a zip code, I'm going to call it text, but I'm going to force it to be a string. So the data type is going to be a text. And just for the heck of it, I'm going to give it a length of 10. Now I'm going to click Save. And now I've got a brand new field here, so I can go Calculate Field. My zip text is just going to be equal to the zip code. I'm going to click Apply. And now let's go to our sort descending here. And now we see 28655, instead of it being right justified, it's now left justified. It's being treated as a text. And those 127 people who died of cancer in this particular zip code have a mean age of 69.29133. The whole goal of this is to generate the data. So I'm going to right mouse click now. I'm going to go to my joins and relates. And now my zip code is going to be my zip. This time I'm going to join it with my statistics field that I created. You can see right here, it wants to join with a text. Now look what we have here. We can see it's one-to-one join has been matched for 81 records. So we have one particular field that doesn't work. Now let's see what we have here. I move all the way over. Look what I have. I have a frequency of 12. So for this particular zip code, 27209, for 27209, and I just froze it and unfroze it, you can see it's got 12 with an average age of 72.25. That's not necessarily important, but it's got the number of deaths right here of 2016. So I'm going to click clear right here, and what I'm going to do is I'm just going to calculate this new field so it's within it, because all we're looking at, these fields right here, object ID, zip code, frequency, mean age, zip text, this is the joined table that we've added to the end of the attribute table for the feature class. So it's relatively temperamental. So I'm going to right mouse click. I'm going to do calculate field. And you can see down here the reference table that it's looking at here. And I'm going to kind of expand this so everyone can see. And I'm going to click on frequency. Remember we had those exclamation points, and then you see that little dot right there which references the table as opposed to the frequency. And now I can right mouse click, remove all joins. Sure, let's remove all joins. So a lot of times when we have these joins here, now I've got the deaths for 2016 is going to be 12. So I can map these. Now what we're looking at is change detection. So I've only done one thing first. Next, let's open up the 2017 data. Let's go over. Let's make sure, okay, we've probably got to do the same exact thing here. We can do it now or we can do it later. We'll do it later like we did before because I can create a zip text, move all those things over as well. But I'm going to create, right mouse click, I'm going to click on my summarize. Just for the heck of it here, I'm going to look at the age years and I'm going to calculate the sum and then go OK. Same exact thing here. We have 1,282 zip codes here, and the other one we had like 1,252. I'm going to do the same thing here because we see this zip code here, 28655 with 132. So I'm going to create my little hamburger menu here. I'm going to go to my fields view, and I'm just going to say, call it a zip text. And I'm going to make this text. I'm just going to give it a length of 10 just to save space. Save. And now I'm going to calculate this zip code over here. So I'm going to turn it from right justified because it treats it as a number because I probably brought this in as a CSV. Excel wants to make it a number. It sees numbers, it wants to make it a number even though we might have some leading zeros from zip codes that were brought in from out of state. So once again, I'm going to go to calculate field. I'm going to calculate that zip code in. You notice it puts little exclamation points there because in the Python programming language, that is for our zips. That's for our fields. And I've done this again. And so now I'm just going to run a new join. I'm going to right mouse click, joins and relates. I'm going to add a brand new join. Instead of deaths, I'm going to be joining with my zip code. And then I'm going to join it to this statistics one. I probably should have given it a better name. I'm going to validate the join just for the heck of it. And you can see a one-to-one join matched on 80 records this time. Okay, that's okay. It looks like we're missing one there. And what do we have? We go over to the right here. We have a frequency of 11. This represents the deaths from the summarized table in 2017. So I'm going to right mouse click. Calculate field. What am I looking at? I'm going to go down here. The frequency. Now I can keep all these. Oh, okay. Oops. I was keeping the old expression right there. Sorry. So I'm going to double click on frequency. There we go. There we go. So now you can see I've got 24 to 9, 11 to 12, 2 to 2. And I'm going to remove these joins once again. So now I've got a column sitting here of the deaths in 2016, the deaths in 2017. So I can calculate the raw change between these, but maybe if we were to go to this, this block group right here, or we're looking at zip codes right here, you would see this one has a much higher population here, 6,000 people versus the smaller one, which only had 3,000 people, which only had 11. So you can see the difference between these. Now, the last thing we're going to do is calculate the population change between these. So I'm going to right mouse click. I'm going to calculate a new field. Now remember, it's going to be new minus old divided by old. Now I'm going to multiply the whole thing by 100. So I'm going to do 100 times. Okay, what's the new going to be? New minus old divided by old. Now, remember our order of operations. So I'm going to put a parentheses right there. So I'm going to calculate number of deaths in 2017 minus the number of deaths in 2016, subtract them, then divide by the total number of deaths in 2016. Can our numbers be positive? Yeah. Can the numbers be negative? Yes, especially if the number of deaths is more in 2016 than in 2017. Okay, so new minus old divided by old. Okay, if we have negative population change, and in this case that's good, death rate's gone down. So even just looking at this one right here, if it goes from 11 to 12, that means it's gone up. If it goes from 12 to 11, that means it's gone down, which is a good thing. And then we multiply the whole thing times 100. So I'm going to click OK here. Okay, let's see what we got here. It says certain rows set to null because why? We have some zeros in there. And that's okay. Let's not worry too much about those. All right, let's see what we have here. One more thing. All right. Calculate field. What did I do wrong? Oops. I did 100 instead of 1,000. I noticed that the numbers there are really big. Okay, it shouldn't be 1,000. I was still on the stuff that we did last night. 100, so we can express that as a percent. My bad. Okay. And I don't want to have to go and re-record all of this, so. All right, so we're going to multiply it by 100. Okay, 100. So now, what do we see here? We got a couple of nulls right here because what happens when we divide things by 0 or we have 0 values here, it's just going to be 0. So we're not going to worry too much about these. And you can see these are overlocated where Fort Bragg is, where there's no permanent population. But now we can see this one went from 6 down to 2, 24 down to 9, 5 down to 2. And then we can also sort descending where we have from 2 to 8. So this is going to be 8 minus 2, which is 6, divided by 2, which is 3, times 100. So this is a 300% increase, 200% increase, 145% increase, 133% increase, which means that it almost more than doubles over 100%. So now we can map these. So I can right mouse click. I can click on my symbology. And I can map these rates right here. So I can look at this. There we go. And then I'm just going to do this with quanta. So now we can make a map here of areas where cancer rates are going down, areas where cancer rates are going up between 2016 and 2017. And then once again, we can go insert, new layout. I'll put it as a letter right here. And now we can insert this map, make a professional looking map here that adheres to our elements of map design and all that other good stuff. I'm going to just click this little button called activate. I'm still learning about some of these things here. Click the little activate button here under my layout, center it, and then I can start to insert all my map surrounds, graphics and elements and all that other good stuff. But we'll go back to this map here and we can answer the questions here. Last thing we want to look at here, I just want to make sure we understand with exercise 3, create a histogram of percent with bins. And so right mouse click here, I can create brand new charts. Last night in class, we created scatter plots looking at the relationship between one variable versus another, and it even gave us an R squared and a line of best fit. Another thing that we can do is we can look at a bar chart right here. What field or category do I want to look at? Well, we went through the trouble of creating percent death change. Let me make sure I know how to do this one here. Oh, kind of flying by the seat of my pants here, so sorry about that. All right, so I can right mouse click. I can visualize statistics right here. There it is. So we've got visualize statistics. I can create 10 bins. This is what it looks like. You can see we've got a distribution right here. You can see we've got a distribution right here, 10 bins. We see the values right here, and then we can see the counts. You can see it's largely located around our 0 values here, but we've got these outliers that are sitting out here, which really kind of make it look kind of ugly. And so we can export these things. The one things that we talk about as part of this exercise, what are ways that we can, we got a lot of outliers here. And so in reality, if we had 190% cancer change, 263% cancer change, it would be really problematic. So at the beginning of class, maybe think of ways that we can kind of make this chart look a little normal. And I think the whole goal in creating this exercise was that looking at from one year to the next, you're going to have a lot of variability between these data. But when we start looking at 20 years worth of data, and we have someone in class developing a database that has 20 years worth of data, you're going to see these things start to smooth out a little bit. So that's about it for exercise number 3. Good luck. I'll expect it to be turned in on time next week, and let me know of any questions in the interim.